Hey guys, welcome to Mr. Tiger Calculus. Today we're going to be talking about how to solve linear and quadratic systems. So what I have here is one quadratic graph and one linear graph, and we're going to look and find where these two graphs intersect. So our answer isn't going to be like x equals 5 or x equals 7. Instead, it's going to be a coordinate. Where did these two graphs touch? And we're going to find that without graphing them, just using algebra. So the first thing we want is we want both of these into y equals statements. Now this one's already y equals, but we want it in standard form. So we're going to FOIL this out and distribute the 1/4. So when we FOIL this out, we get x squared minus 6x plus 9. And then when we distribute the 1/4, 1/4 x squared minus 1.5x plus 2.25. So there's my quadratic equation that I'm going to use. And on this one, in order to get y by itself, we'll subtract that 3x over there and then divide everything by -2. And we'll get y equals 1.5x minus 6.5. So these are the two equations that I'm going to use. So we want to find where these two graphs intersect. So where are these two graphs the same? Okay, so when are the x and the y values exactly the same? So what we're going to do is take these and we're going to set them equal to each other. So just write them both as a new equation. But instead of equals y, we're going to equal this other equation that I have. And now we're going to solve this just like any other quadratic that we've been working with. We want this equal to 0. So we're going to get all of this on the same side. Now, in order to make our lives easier, I'm going to multiply this by 4. I'm going to get rid of that 1/4 so I can factor this out. So 4 times 1/4 is just x squared. 4 times -3 is -12x. And 4 times 8.75 is 35. So now I can factor this out to find my solutions. Factors of 35 that add up to -12. Actually is -7 and -5. So my solutions are x equals 7 and x equals 5. So normally what we were doing before is that's where we would stop. These were our solutions. But this time I'm looking for a coordinate. So all I have now are two x values. I need to find the y values to show me where these two graphs intersect. So what I'm going to do is I'm going to take both of these and I'm going to plug it back in. It doesn't matter which equation that I choose. I just need to plug it back into the equation. Now I'm going to plug it into our linear equation. That's typically easier because we're not dealing with an exponent. So I'm going to have to solve y equals 1.5, and then for x, I'm going to plug 5 minus 6.5. But I also need to solve it with 7 plugged in. Y equals 1.5, and we're going to plug in 7. So what we end up here is y equals 7.5 minus 6.5. So y equals 1. And we've got y equals 10.5 minus 6.5, which turns out to be y equals 4. So when we plugged in 5, y was 1. And when I plugged in 7 to the linear function, y was 4. So our two solutions are 7, 4, and 5, 1. That is the solution to this linear and quadratic system. If I were to graph both of these in the calculator, I would see that they intersect at these 2 points, and those 2 points only. All right, we'll look at another equation and see what happens maybe when these don't factor. But it's roughly the same. We've had a lot of practice doing this. First thing is we want both in y equals. So I need to subtract this x here and then divide by -1 because I don't want that -1 there. So I'm actually going to get y equals positive x minus 6. So there's my linear function. Now here I need to FOIL this out. And when I do that, I'll get x squared minus 6x plus 9. I need to distribute that 1/2. 1/2 x squared minus 3x plus 4.5. And then I need to subtract this 1 over, because I don't want y plus 1. I want y, just y by itself. So the actual quadratic equation that I'm going to use, 1/2 x squared minus 3x plus 3.5. So there are my two equations that I'm going to use. Now again, I want to see where these two graphs are the same, so I'm going to set them equal to each other. 1/2 x squared minus 3x plus 3.5. Now I'm going to look for the solutions to this graph. So I'm going to add 6, and I'm going to subtract x. And I find out 1/2 x squared negative 3 minus 1 is negative 4x. And this is going to be 9.5. I'm going to multiply this by 2 to get my a value as 1. Be x squared minus 8x plus 19. Now, this does not factor. No factors of 19. Okay, this one I can't even divide by any whole number. So what I'm going to do is I'm going to use quadratic formula. So we've had some practice doing this. There's my a, b, and c values. So I need negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c. And all of that will be over 2a. Now, 8 plus or minus, when I solve for my discriminant, this part underneath the square root, I would find that my discriminant is negative 12. What we know about the discriminant says this is going to be two non-real solutions. So what that tells me is there is no solution to the system. Because if I end up with two non-real solutions, that means these graphs never touch. So to check your answer, if you were to plug this into the calculator and hit graph, you would see a quadratic and a line that do not intersect at all. So this happens sometimes, and it'll happen when you have two non-real solutions. All right, so this is pretty simple. You want two graphs set into y equals format. Make sure your quadratic is in standard form, not vertex form like this right here. You're going to set them equal to each other because we want to see when they are the same. And you're going to go about solving this exactly how we've solved all other quadratics. Okay? Either by factoring, using quadratic formula, maybe completing the square. And then once you have your x values, you only have two x values for two coordinates. Plug your x value back into your equation. Probably you're going to prefer your linear equation, and you'll find out what y is, and you'll have two coordinates. All right, thanks for joining us here on Mr. Tiger Calculus. We'll see you next time.